you. Okay. Hi, everyone. Thank you for coming to Don't Tempt State. Don't Tempt Fate, Maintain State, using durable objects with Cloudflare. And I think this talk is mainly about why you should have developer or durable objects in your developer toolkit, and why I think it is the most underrated, underappreciated storage and compute offering that Cloudflare has. So today, order of operations, the agenda. We'll be going over the Cloudflare developer platform. Many people we've talked to here know us for CDN, DDoS protection, security. So quick overview of what the dev platform entails, as well as what are durable objects, why should you use them, why do developers love them, and why do they wonder about the name. People have opinions on the name. The actor programming model, not one, but 2 demos will include who here generates code with AI? Okay, more than I expected from some conversations we've had, but glad to hear it because we will also be doing that. How durable objects work and why they're better than traditional serverless state offerings, and a quick durable objects versus key value store. So I'm Lizzie. I'm a developer advocate at Cloudflare. Studied computer science and I loved hackathons. So I was like, I want to make demos and educational content for work. And here I am. I love playing around with a lot of developer tools. Let's talk afterwards about APIs. Yeah. But mainly I use the developer platform at Cloudflare, which offers everything you need to build serverless apps. We have global compute, storage, and different full stack services like image optimization and video streaming. And we have network infra that scales globally on demand. Cloudflare covers security, configuration, and maintaining infrastructure via APIs, so you can easily integrate with your existing tech stack and focus on writing code or generating code nowadays, maybe. Who here has used Cloudflare Workers? Okay. Many people we've talked to at the conference have not, but a few have. So it's a serverless platform where you write a fetch handler that processes requests and then returns responses. We have JavaScript, TypeScript, and Python support. And if you're a Java developer, I firmly believe it's pretty beginner friendly and anyone can use Workers. You upload your code to Cloudflare and they handle the deployment and execution. Unlike traditional serverless platforms, Workers uses a unique runtime and operates globally across all of Cloudflare's data centers, effectively making planet Earth, the only region. When you deploy a worker, it runs in the nearest Cloudflare data center to the user. This global distribution in spanning the globe ensures low latency. Developers host and build a lot of super fast, scalable serverless applications, websites, and tools on Workers without managing infra. However, it is stateless. And in the handler, there's nowhere to store global state. You could throw things in global scope, but that's not usually what you want. Because Workers runs in so many different places all around the world, and each location has hundreds of servers. So Cloudflare has different storage options. We have D1, which lets you build serverless relational SQL databases with point-in-time recovery. Durable objects lets you maintain strong consistency of state across multiple clients, events, and connections with single-threaded servers spread across the world. Unlimited as well. We have Hyperdrive, a service that lets you make your regional database feel global. And you can, with KV, store, modify, and query key value data, probably non-dynamic data. And R2, we have S3 compatible zero egress fee object storage. And we'll be focusing on durable objects, of course. There are two hard problems in computer science. We have cache invalidation, naming things, and off by one errors. Durable objects, as my former VP Rita says, it's hard to define, hard to describe. But people have a lot of thoughts based on the name. So durable objects are like starting a new server for every logical session, not every request. Wow. John thinks it's not a good name. He's not alone. We've heard that a few times. But what do you call something with containerization, service discovery, and storage together in one thing? Durable objects, something that is a lot of things. Maybe we'll rebrand, but ultimately, developers enjoy it. And before I worked at Cloudflare, I've been here since April. I was also a user, so I enjoyed the products, and now I get to build the products that other people love. Name sticks, and so does developer love. So let's talk about state, or more specifically, the pain it is to manage it. You could just throw everything into a database, but then every time you need data, you need to politely ask, request, and wait for it to respond. If it's slow or overloaded, your app is just sitting there, staring into the void. We have latency, could be an issue. Imagine you're a multiplayer game, and with every player move, you have to make a request to a central database before anyone sees it. By the time the move registers, your character is dead, or worse, stuck in some quantum superposition of moving and not moving. And if you've ever dealt with multiple servers trying to update the same data at the same time, you know the horror. Two people edit the same document, the text goes away, the text, half of it stays. Who knows where the rest of the text is? Here we have traditional database serverless systems that are chaotic and inefficient. Users and requests are scattered across multiple servers and databases, leading to disconnects and complex architectures. They struggle with real-time, long-running multiplayer apps due to the request response model and lack of proper WebSocket support. Solution: durable objects offer a more streamlined approach. Each chat room is managed by a single durable object with users connecting via a WebSocket. This eliminates disconnects and the need, it simplifies the architecture, making it ideal for real-time synchronization, multiplayer games. Durable objects provide strong consistency, low latency, and seamless state management, solving the limitations of serverless systems and avoiding database bottlenecks. Each durable object is a globally consistent, distributed instance that can maintain in-memory state across requests and coordinate across multiple instances, particularly powerful for building stateful apps. It's built on top of Cloudflare workers, edge compute, and each durable object instance has its own durable storage, like a key value store, persistent across memory, requests, and it executes in a single-threaded fashion. So you decide the location. It will automatically spin up any location close to you, but you can also say spin one up closer to users or in a different specific geographic location. Objects maintain their state in memory for fast access, kind of like computer RAM, while also persisting to disk. Multiple requests to the same object are serialized, preventing race conditions. And it can handle complex business logic and state mutations. Workers can send messages to a durable object by its unique name, ensuring that all requests to that name are routed to the same instance. support for WebSocket connections, and long-lived sessions, and you can coordinate between multiple clients and requests. There is automatic distribution across Cloudflare's global network, and objects are created on demand where needed. You can have unlimited of them, so unlimited power, Star Wars fans. The actor programming model is a framework for concurrent and distributed computing where actors are the basic units of computation. Each actor is an independent entity operating asynchronously, enabling them to run in parallel across multiple machines with its own state and behavior, communicating with other actors, sending and receiving messages, and deciding what to do with the next incoming message. Actors process messages one at a time, ensuring sequential execution and avoiding shared state concurrency issues like race conditions. It has its own private state and can decide how to process the next message based on that state. Let's say this state is a balance $5 and the incoming message is saying add $2 to that. It gets the message and updates the state. Now it is $7. And for that next message, the actor has this new state. Actors don't share memory and interact only through immutable messages, widely used in systems needing concurrency, distribution, and real-time communication, like Erlang, and durable objects for stateful, global, distributed workflows. So, durable objects are single-threaded, and each durable object runs in exactly one location in one single thread at a time. Each object has its own private on-disk storage, which is very different from a typical database where many clients may be accessing the same data. In durable objects, any particular piece of data belongs to exactly one thread at a time. I could keep on talking about it, but I'm going to show you. If you go to, forgot to say, go to that QR code. If you go to this QR code, we can all play a game together. It's kind of like Google Docs, but real time. I guess Google Docs is real time, but built on Cloudflare workers with durable objects. This is it. I already did this. Refresh. Yes. Real time. See that? My coworker Sunil says that this is risky, and he gives it 20 seconds until someone writes something that they shouldn't. But I trust you all. Looks good so far. I could open this, another tab. There it is. Some of that did not go over. It's only, someone erasing? I forgot, everyone has the power to erase, clear all. Anyways, let's dig into that code. Okay. Here we have our durable object class. We have an array of WebSockets. We keep track of the different strokes we all make, and we keep track of state. We ensure that initialization happens immediately. No requests are delivered until the initialization is complete. That is what state.block concurrency while does. And initialize, we load all the existing strokes from durable object storage. More robust retrieval is storage.get. We have our strokes, persistent strokes. If the strokes exist, we limit to the most recent 1,000. I feel like it was getting overloaded when I was testing it. So 1,000. We limit the stored strokes to prevent unbounded growth. else strokes is an empty array. We have a fetch handler. We handle WebSocket connections. We check if it's an upgrade. New WebSocket pair is from Cloudflare to handle WebSocket connections. Then we handle the session. That looks like this. We accept a WebSocket connection, add that session to our list sessions, send the current state to the new client, including the strokes, and parse the message as it comes in from the WebSocket. If it's a drawing case, we save the location, the color, the size, timestamp, and add that new stroke. Save to durable storage with put. And I think that's very handy, get and put. And if we clear, set it to an empty array. And then broadcast to everyone. So this is how we can all see it when we go to that deployed site. And you can also run it locally as well, and it will maintain state in different tabs if you're testing locally. Remove session on close, broadcast. And this is called from our fetch handler in our Cloudflare worker. If we hit the draw endpoint, else we return the HTML, static HTML page, which is here. And I did use DeepSeek to generate this. That is all good and fun. Let's make a counter app. We're going to run one of my favorite commands, npm create Cloudflare. If you've used workers, you've probably run that to create a new worker. I'm going to call it Jfokus. You start with a hello world example. Hello world worker. Let's do JavaScript for now. I've been enjoying coffee while in Stockholm. I think we're going to make a polling app. We can all vote on coffee, latte, or espresso. Feel free to send your Stockholm coffee recommendations. Here we have our new worker. Just says hello world if we were to open it. Now we're going to do what all good programmers do, which is copy and paste code. We have HTML for our static web page. Let's make a new file. Save that in a static folder. Call those HTML, index.html. Come on. And in our worker, we have our counter class, which has state, and we initialize the counters. We get the durable object latte, where it starts at 0. Same with an espresso counter. So we can vote on latte or espresso. If the path starts with increment latte, we will increment that count. We'll get the put. Same with espresso. Copy and paste this. That is our index.js. I've been hesitant with DeepSeek. Often the server is overloaded. I guess too many people are using it. And Cloudflare does also host DeepSeek, so you can use the open source model with a few lines of code if you wanted to. Then also need to edit our wrangler.json file. So we have a binding for a durable object, durable objects, and it says bindings, name is counter, class name counter, bindings. name, class name. This is an array. Only recently did wrangler.json file become wrangler.json. It used to be wrangler.toml. Name is all caps, class name, lowercase. And this is our binding, so this is how we access the durable objects binding in our Cloudflare worker. We have migrations, tag, v1. This is needed for durable objects. We have tag, v1. So when I generate code, it's often still in a wrangler.toml format. Okay. And it sees there are errors because there are comments in wrangler.json. So if we, but it will still run. I've also been renaming the file to .jsonc. Okay. So here if someone were to click the button, we would increment the latte state. npm run deploy class name counter class name binder counter bindings. Oh, that should not be an array. Okay. Deploy our worker. I have different Cloudflare accounts. This one will be employee account. New version of script does not export class button counter. Name it, rename class. I think there was an issue as I have been making different versions of these. So for now, let's look at a version I have on GitHub with the same code generated by DeepSeek. Have counter. Focus counter dot dev. Okay. It's not deployed. Okay. Was deployed. Okay. Well, that live demo is not working, but you can see this code on GitHub. Let's go back to talking about durable objects. Okay. Okay. Clicker is not working. Okay. So how durable objects work. Every durable object is tied to a unique key, which defines its scope and identity. This key determines the specific durable object instance that will process requests. The persistent state storage with the instance can be accessed via API call to that key. For example, a use case in a multiplayer game, each game room could be represented by a durable object with a unique key that's like game room 123, game room 456. Requests targeting this key are always routed to the same durable object instance, maintaining a consistent view of state. And like a worker, durable object is automatically provisioned geographically close to where it is first requested. It starts up quickly when needed and can be spread around the world. And it can optionally say where they are. It's like, put this in Stockholm, put this in Berlin. Cloudflare ensures that the requests are routed to the nearest durable object instance, and this reduces latency. When users from different regions can access the same instance, Cloudflare routes the traffic to the nearest one, which is handy GDPR and other geographic apps. Durable objects in Cloudflare can be thought of as virtual cloud-based computers that persist state across requests, unlike traditional serverless state functions. They function similarly to Erlang gen servers, maintaining long-lived processes that handle input, perform computations, and return output, while keeping in-memory state and persistent state. Durable objects follow this model but exist in the cloud. Stateful sessions, instead of treating each request in isolation, durable objects allow for stateful interactions, making them ideal for scenarios like user sessions, shopping carts, profiles, or collaborative applications like multiplayer document editing and drawing. And they provide WebSocket support, unlike traditional serverless functions, enabling real-time updates in applications like collaborative editors. You can coordinate multiple sessions. They offer persistence and scalability while they go to sleep when idle to conserve resources. They persist state via storage and can be distributed across machines. You can build game engines and run AI models from a durable object. Traditional serverless offers more steps, but durable objects offer consistency without complexity. I think the key advantage over traditional serverless approaches is that durable objects provide a much simpler programming model for building stateful apps. Instead of managing complex distributed systems with external databases, message queues, or cache layers, developers can write code that looks and feels like regular object-oriented programming while getting the benefits of distributed computing. For example, implementing a distributed counter traditionally might require database for persistence, cache layer for performance, lock management for consistency, and queue systems for coordination. That's a lot. There's no need to connect to or manage external databases. State is maintained close to where it's needed, and there's automatic coordination between instances. You pay only for the actual compute and storage used, and there's no need to provision or maintain database instances. Automatic scaling without over-provisioning, and reduced bandwidth costs due to edge locality. When to use durable objects: real-time apps, chat systems, live dashboards, a lot of data you can do in real time, which I think is very fun. Session management, user sessions, coordination, queue management. It's versatile and simple. Durable objects versus KV. You saw the tweet that was like, what's the difference? I think durable objects is like glorified KV. Durable objects offer low latency but higher latency than KV because they provide strong consistency and stateful computation. They're more for real-time, fast updates where consistency and coordination are critical. And Cloudflare KV is lower latency, but it's probably like less dynamic data. And it's eventually consistent but not consistent like durable objects. What's next? Durable objects enables stateful edge computing by allowing developers to maintain state directly on Cloudflare's global edge network, reducing latency and eliminating the need for centralized servers. SQLite running in durable objects provides a familiar, lightweight solution with the added benefit of global distribution and stateful persistence. It simplifies building apps that require durable object storage without complexity, and with automatic scaling, you can scale instances horizontally across the network. State is kept close to users, and each object is independent, improving fault tolerance. Because you can interact with durable objects via HTTP requests, WebSockets, or plain functions, and they'll keep running, maintaining their state and performing tasks, this makes them perfect for AI agents that need to perform tasks like sending an email, searching the web, scraping the web, and more. Okay. So don't tempt fate, maintain state with Cloudflare durable objects. When a request comes in, Cloudflare either spins up a new instance or routes it to an existing one. Each object processes one request at a time, preventing race conditions, and each instance of a durable object is tied to a key, ensuring that all requests to that key go to the same instance. Real time. Further resources. This is a cool website that tracks where durable objects are made. When you load this website, realdurableobjects.live, it says that a worker in Stockholm created a durable object in Stockholm. Yeah. We have further resources, and there will be a QR code next, so you can get links and the slides. Shout out to Sunil Pai, the founder of PartyKit, and a big durable objects advocate. He makes a lot of blog posts and educational content on what you can do and build with durable objects. So a lot of his blog posts here. Thank you. QR code to slides with resources and code samples. I'm Lizzie. You can find me online here. Thank you. And if there are any questions, I will be off to the side here.